on when the particle is moving to the right, to the left, and stopped. But I only care about the interval 0 to pi. So if I want to know when it's basically its motion, I analyze the velocity. Well, good news, I already have the velocity function, right? So I need to kind of picture, I think a graph helps. Remember what that looks like? What's a sine wave? Stretch 3, correct? You know, something like that, right? If I need to know the axes, what's the period of this function? Pi, because you do 2 pi over b, which is 2. So this is pi, right? Which makes that pi over 2. By the way, that's just graphically. We could do that algebraically. When we set this equal to 0, it equals 0 when the inside equals 0, right? It also equals 0 when the inside equals pi, right? The sine of pi is 0, which will give me pi over 2. It also equals 0 when the inside is 2 pi, which will give me pi, and by then I'm outside my interval, right? You got to keep checking in both directions till you're outside that interval. So now you see the 0, pi over 2 pi. Personally, I think graphing, if you remember your graphing rules, is easier to picture. Because you see here, this is velocity, and you're positive here, negative here. So let's answer the question. Moving left, I'm going to start with left, on what?
Pi over 2 to pi.
Pi over 2 to pi. Moving right on 0 to pi over 2, which means it stopped. And yeah, it does sound pretty obvious, but we do need to say it. Stopped at t equals pi over 2. Now, I don't need to put 0 in pi. Why? Right. Look, it's not equal to, right? But if these were equal to, you better include it in your answer. Nothing new there, right? Hopefully. Let's find the particle's displacement. Particle's displacement. Now, displacement is defined before f of b minus f of a, but I don't have f. It's the integral of b of t dt on a to b. So in our case, the integral from 0 to pi 3 sine 2t dt. Yeah? How do I do this integral? Substitution. U is 2t, which means du is
2 dt.
2dt, which means dt is 1/2 du. 0 becomes 0. Pi becomes 2 pi. So I have the integral of 0 to 2 pi 3, bless you, sine u times 1/2 du. You with me there? That's really just 3/2 sine. What's the antidote of 3/2 sine?
Negative 3/2 cosine.
Negative 3/2 cosine u. Everyone agree with that? Going backwards, be careful of the negatives. Plug in 2 pi. What is cosine of 2 pi? 1. So I times it by that, I get negative 3/2. What's cosine of 0? 1. So I minus negative 3/2. It's really plus 3/2, which is 0. 0 what? Meters. Yeah, it is the displacement. Now, does that mean it didn't move? No, we know from part A that it did move left, move right, it just happened to move the same amount in both directions so that it looks like it didn't move back to where it started.
It's a sine wave, doesn't always have a better displacement if it's not.
It depends on the interval you're given. Because if I was given the interval of 0 to pi over 2, no. Or 0 to 3 pi over 4, that kind of thing. So it all depends on your interval. Part C. If S of 0 is 3, what is the particle's final position? This would be such an easy point on the AP test. This is where it started, correct? How much did it move? 0. So it is now at 3 meters, correct? Does that make sense? We found in part B how much it moved, the displacement. Really moved nothing overall. Now it's still at 3 meters. Find the total distance traveled. Total distance traveled. Okay. So this is the integral 0 to pi, absolute value of 3 sine 2t dt. Correct? Total distance traveled is the absolute value of that integram. But by hand, you cannot do that integral by substitution. By hand, it means you literally have to rely on the graph and do pieces. Right? And we already know what the graph looks like. Like that, right? So I need to find this piece, add it to this piece. Now, if I were smart, kind of like Jay was saying, it's a sine wave. It's symmetrical on this interval. So if I were smart, I would find one area times by 2, correct? But let's actually work through it, because they don't all work out that nice and neat, of course. Especially with parabolas and stuff like that. So, I need to find the integral of 0 to pi over 2, 3 sine 2t dt. Take the absolute value of that, add it to the absolute value of the integral pi over 2 to pi. So this is actually what's going on. I'm finding the absolute value of the positive piece, the absolute value of the negative piece, and add them together. Like I said, we're going to be smart and just find one of them, times it by 2. Okay? Now, it's pretty easy because didn't I already do this derivative, or antiderivative? And got 3/2 cosine u. Yes? But here's, I better be careful, it's not 0 to pi over 2. Because didn't I initially say u is 2t? So 0 becomes 0. Pi over 2 becomes pi. So be very careful. We can kind of use the work we did previously, but we have to be careful of our interval. When I plug in pi, what is cosine of pi? -1. -1, so I end up with positive 3/2. And when I plug in 0, I get 1. So I get minus 3/2. So 3/2 plus 3/2 is?
6/2.
Which is 3. I heard a few 6/2 on there. Now that's just this piece, correct? And I'm going to, I bet you, 6 meters. And that should make complete sense when we really think about this problem. On 0 to pi over 2, I moved 3 meters to the right. But I have to move the same amount if my displacement was 0, so I had to move 3 meters to the left, which is a total of 6 meters. Should make sense, right? Questions? Grab your calculators, let's do this on our calculator.